So we're going to start with the review packet here. If you haven't done the warm-up already, go ahead and do that. I'll give you a second to do the warm-up. Oh, you're going to have to move because Billy's here now. You did the warm-up yesterday, so is everyone good with the warm-up? Okay, so I will show you, thank you. I will show you the answers. If there's one in particular that you didn't get, raise your hand and I'll do it on the board. Did everyone get these? Make sure you have these numbers, the work with them, everything. If you don't have these right, the rest of it's going to be pretty tricky. Are we okay with these 4? Billy, can you pull out your packet? Thank you. So it looks like everyone's good. I see not everyone has answered that question at the bottom. Super important to answer, so if you haven't answered it, go ahead and take a second to do so. Shouldn't take too long. In each of the problems above, what did you have to do to get the denominators to be the same? Does someone have an answer for me? Yes. Multiply. Yeah, so you have to multiply. You have to get a common denominator by multiplying. Top and bottom by a factor of 1, whatever that factor of 1 may be. Here it would have, for 1/3, it would have been 5/5, and for 2/5 it would have been 3/3, so that you could get them both with a denominator of 15, right? So have something written for that. That is a nice candidate for notebook check or something. Coming at you in like a week from now, by the way. Notebook check. All right, moving on. Whoa, that's a lot. Whoa, that's a lot. Example 1. Oh my goodness. Example 1. Come on. Part A. This is already filled out. I'm just going to walk you through example 1. I'd copy this down if you don't have something like this. If you have it and it's accurate, leave it. I just want to make sure I go over one with you and give you more time to look at it if you didn't do so good the first time around. So we have 3 steps when we're trying to combine rational expressions. Step 1, find the LCD. Find the least common denominator. This is an expression, x plus 4. This is an expression, x plus 2. On the other page, we had denominators like 3 and 5, where we had to multiply them together. Here we have x plus 4 and x minus 2 that we're multiplying together. Do you see how that's related? Yep. Yeah. I'm sorry. I wish I had more time, but that's why I'm doing this today, because I knew that I needed a little bit more time with you guys. It's the same idea though as in the warm-up where it's just numbers though. So you have like 1/3 and 2/5, I think it was, and so your common denominator is going to be 3 times 5. So now we have x plus 4 and x minus 2 as our denominators, and our common denominator is just them multiplied together. Just looks a little funny because they're expressions. Step 2 is to rewrite our fractions, our original 2 fractions, with, oh my goodness, this is killing me. Rewrite each fraction with the LCD. So let's look at this first fraction right here. This is what we started out with, right? But we're missing the x minus 2 from the LCD, so that's why we're putting the x minus 2 in the denominator. But you can't just add some factor of x minus 2 anywhere. That's why we have to multiply the top by it too. It's a factor of 1. 2/2 is 1, 5/5 is 1, x minus 2 over x minus 2 is 1. So we're allowed to do this. And the reason we're doing it is so that we can get our least common denominator and combine the fractions. This is what we started out with, x over x minus 2. We're missing the x plus 4 portion. Multiply top and bottom by that. Step 3, I should shade. Well, it doesn't matter. Step 3 is down here, but this is the work for it. You're just combining like terms. So the x squareds come together to give you 2x squared, and the negative 5x and the positive 4x come together to give you negative x. You have plus 6, and then you have your LCD on the bottom there. You can see the answer for this, but when I check this on Monday, this isn't all that should be there. So I'd like you to take a moment and do steps 1, 2, and 3 and make sure this is what you get if you haven't already done it. If you've already done it, then you're golden. If you need me to do it, last period I had to do it out because they weren't quite sure how, and that's fine. I can do it. I can extend the page and we can work through it. So go ahead and give it a try. If we're good, I'm going to go ahead and move forward. Oh, just kidding. I'm not going to move forward. I'm going to let you guys do the rest as homework over the weekend. If you didn't already do it. If you already did it, then you don't have that as part of your homework for the weekend. But I'm giving you extra time. So we did the warm-up in A and B. So you have 2 more pages, page 3 and page 4 of the review packet to do if you haven't already done it. But we're going to stop there with the review packet because I'm going to let the rest of it be homework because it should have all been homework. But I just wanted to make sure you guys were on the right track. And we're going to jump over to 1.3, Part 3, notes. That's our goal for today, is to get through 1.3, Part 3 notes. I really think that this section of notes is not terrible. 1.3, Part 4, I think, is the last section in this packet. That's a little bit trickier. That's for Monday, and that you'll need to bring your A game for that. But today, I think you guys can handle this. This isn't too terrible. So the first thing I want you to do before we get started, from memory, fill out all those charts. You're going to have a quiz for accuracy next week, remember? So make sure you fill that out as best you can. No. I'm actually going to highlight our given information in this problem. That's important. That's super important. And they're asking us to find the values of each of the trig functions below using the trig identities that you just filled out in your warm-up, okay? So this is going to be kind of similar to the process you used in that bookwork where you had something given to you and something to find, and you had to find something that was using both of them. So we have sine of theta and cosine of theta given to us. We need to find some identity that's going to help us solve for cosine of theta. So if you need to flip back to your warm-up, take a look around, see if you can find something with sine of theta and cosine of theta. Does anyone see anything in particular that will help us? Oh, Alex, yeah? That's a good idea, but we are only given sine of theta, and we're only asked to find cosine of theta. And if we use that, we have tangent of theta, and we have 2 unknowns, and we can't solve for 2 unknowns. Yeah, we could do that. Yeah, I like that. So I'm going to write step 1, because I like to give you guys steps. Choose an identity with sine of theta and cosine of theta. Why didn't we use our cofunction identity with sine and cosine? Does anyone know why we couldn't use that? You know, sine of 90 minus theta equals cosine of theta. Why couldn't we use that? Does anyone know? Why couldn't we have used the cofunction identity sine of 90 minus theta equals cosine of theta? Because that has sine and cosine in it. We don't know the sine of 90 minus theta. They gave us the sine of theta. So we couldn't get anything else involved. Like sine of 90 minus theta, we don't know that. We only know the sine of theta. So that's why we couldn't use that. I had someone else suggest that in my other class. Just thought I would clarify why we're using sine squared of theta plus cosine squared of theta equals 1. Do you remember me saying that sine squared of theta is just our silly way of writing sine of theta squared? It's just the notation. So if that bugs you, you can write it like this is just how mathematicians write it. This is the proper way to write it. If this helps you mathematically, these are equivalent. It's the same thing. So with that being said, what do you think our step 2 is going to be? We have something given. We have one unknown. Where do we go from here? Anyone? Yeah? Yeah. Plug in the info that you know. So that leads us to 0.6 squared. It has to be squared. Sine of theta is squared, and we have sine of theta here. Plus cosine squared of theta equals 1. Step 3, solve for unknown. What is your first thoughts here now? Anyone have any ideas? We're just solving for cosine of theta. That's what they're asking us to find. This is kind of just like algebra. We're right here. Where do we go from here? I heard something. Yeah? Yeah. Right. I like that. So get the variable alone, cosine squared of theta equals, he said subtract it from both sides. You're going to need your calculator. We're doing some math here. I don't know if you knew that. Cosine squared of theta equals 1 minus, what is 0.6 squared? 0.36. Okay, so cosine squared of theta is what? What is this? 0.64. Very good. All right, is that our answer? No. Yes? You square root both sides. Remember, I wrote up here that this is the same thing as this. How would you get sine of theta by itself? You would square root it. So I'm going to square root both sides. So that gives me cosine of theta, square rooting and squaring. Cancel each other out. Square root of 0.64. Anyone? 0.8. That's your answer. So now you have sine of theta is 0.6. You know cosine of theta is 0.8. This is your information for this problem. You are now asked to find tangent of theta. What can you use? Can you use, what are the things that you're given now for this problem? Because you're asked to find tangent of theta. What are you given? Yeah. We do. We have cosine and sine now. So what can we use? What identity? Go ahead and give that a try, and we'll check back in a couple. All right. I see most people used. Billy, can you tell me which one you used? Tan of theta equals sine of theta over cosine of theta. So we know sine. So this was step 1, finding an identity. Step 2, plugging in what you know. We have 0.6 over 0.8. Step 3 is just solving. That's 0.75. That's your final answer. Did everyone get that one way or another? David, can I ask you what you did? One divided by point. No, you were right. Yeah, 0.8, because it's, so what he used was, I should write the original. Tangent squared of theta plus 1 equals, what's the original? The original identity. Right. So he used this one, and he changed it to 1 over cosine squared theta. From there, you have your known and your unknowns. So you can go tangent squared theta plus 1 equals 1 over 0.8 squared. What is 1 over 0.8 squared? Do you have that number? Make sure you do 0.8 squared first. So 0.8 squared would be 0.64, right? So 1 over 0.64 is what? I'm just asking for this calculation. Oh, you just did it like that. And then you could subtract 1 from both sides. Can someone do this in their calculator? What is point what? 0.565. Okay. So it's about that, but we're not quite done yet because we still have, yeah, we're doing it the hard way. But the point of me doing this out is not just because David did it, but because there's many ways to do every single one of these problems because there's many identities that you could use. So if you see your neighbor doing something that you're not doing, it's not necessarily wrong. And this should be 0.75. So just know that if you're not seeing a way that I'm doing it, it's not necessarily wrong to look at it a different way. There's many different ways to do these problems. So that was awesome that you saw that. Good job. We are going to do example 2, part A together, and then you guys get to do B. All right, I'm going to highlight what we're given. That is that tangent of theta is 3. What is the relationship between cotangent and tangent of theta? They're both theta. We don't have like 90 minus theta or anything, so that kind of kicks out the idea of cofunctions. We just have cotangent of theta and tangent of theta. Nicole, do you know what? Yeah, it's the reciprocal. So she's saying cotangent of theta is just 1 over tangent of theta. That's 1, finding our identities. 2, cotangent of theta, we're plugging in for what we're given, 1 over 3. In step 3, we don't need to do because that's done. You could write it as a decimal if you so choose, but that's just fine as your answer, 1/3. The trickiest part really is finding the relationship between the given and the unknown. If you could take a moment to do part B, secant of theta. So you're given tangent of theta and you gotta find secant of theta. Ready, set, go. So as far as this is concerned, on your agenda, it says for tonight you have some book work, and it's very similar to what you did, I think, Tuesday and Wednesday night. I gave you an extra day to fix it up. That book work where it said like 17 parts this and this, 18 parts this, and it was 17 through 22 different parts. You're doing 17 through 22 the other parts, basically. So that's your homework for over the weekend. But remember, if you didn't do your rational expression review last night, that's also homework. So you have last night's homework due Monday also if you didn't do it. I will be checking both on Monday. And that rational review should be really good because we did 2 of the pages together, and I'm giving you an extra day. So that should be just perfect. But other than that, you just have book work and the rational review. I personally think it would be best for you guys to maybe get the rational review out of the way. Maybe start that now just because you have your packets out already. And that way you can ask me any questions because that's a review, so that should be pretty quick. So if you have any questions, we can clear that up now before you have to leave for the weekend. And hopefully the book work will go smoothly after that. I see some people working on the rational expression review, so that's good. But other than that, I'm done teaching for today. So this is from Tuesday. Okay. Yeah, Tuesday night.
I think this was due on Tuesday. I'm not sure what was due on Tuesday.
Okay. Let me make sure. 18B and C, 18B, 19D, 20. Okay, that looks good. Let me go back. Holy cow. Making some noise. Let me go back and make sure I mark everything for you because you want to get credit for this. Pencil. You need, what are you missing? I gave you, I must have seen this already.
I was absent.
I know, but we had it as, like I gave it again as homework the next day too, so maybe.
No, like Monday, I was in school. I think the homework was this. And then
What is that?
I'm not sure.
What's it called? Oh my goodness. The homework, so the homework would have been, this is the classwork. This is the homework.
Okay.
So, reciprocal. Oh, you know what? I didn't check this. So you're fine until I told them, yeah, the notebook quiz, I told them that would be on there because I didn't check it specifically. But other than that, you look fine. You, in case you're curious though, you did get a 0 on the tangent worksheet in that packet.
I mean, I'm not.
Okay. All right. Yeah, that's yours. Okay. You're okay. Yeah. Oh, by the way, also, everyone did really well on those quizzes. So, I'll give those back to you as soon as I can. Did I say this to you already? What is going on? It's Friday. I'm sorry. Whew. Quizzes. Oh, we're almost done with 1-3, right? We're like at the end of the packet. I said this to my other class, so I thought it was fair. If we're getting close to the end of this, I told you that we're having a test on 1-1, 1-2, and 1-3. So we're almost done with 1-3. So next week, I think next Friday is the notebook check, and then like the following week will be your test. So just to give you a heads up, if you want to start filling in things you didn't fill in, that'd be probably wise now because a week from today is what it's looking like. I don't know yet. I mean, it depends on. We might have to do pacing. It's just my idea of what is going to happen, but we'll see. No, I know that the notebook quiz is going to be probably Friday. Well, next week sometime. So you got to get ready. If it's not Friday, you have to get ready even faster. So you should be questioning me. You said thank you if it's Friday. No, I'm not.